Okay, in the last lesson here, we're going to take the difference between uh, two types of nuclear reactions. We have the first kind called fusion, and it comes from its name. Fuses means small things, when they combine together, they form one large thing. It's the same here. When small nuclei combines to form large nucleus. طيب, how does this happen? This, this does not happen except near the sun. Why? The fusion reaction needs very high temperature, that small nucleus, as if they melt, to combine to form large nucleus. So this process, it does not happen in life, because to happen in life or to do such reaction, it needs very, very high temperature, which is nearly the temperature near the sun. So it will be that expensive. So it does not need, so we don't use it. It just happens near the sun. And this equation, you have to memorize it, because I may ask you to write the equation concerning the fusion reaction, that for each 4 hydrogen, okay, when they combine, they will form helium, and 2 positrons are formed, and great amount of energy released. So in the fusion reaction, the hydrogen nuclei fuses with great amount of energy, and at the same time it releases to a great amount of energy, which helps that this reaction is repeated over and over again near the sun. So we say here that fusion reaction, in which small nuclei combine, release much more energy even than the fission reaction that we're going to take here, in which large nuclei split apart and form smaller nuclei, which is the fission. However, fusion occurs only at very high temperature. This means although this energy is very, very high, okay, but it needs even more higher temperature to start such reaction. That's why this reaction does not happen except near the sun. Okay, what about the fission reaction? Fission reaction means that the nucleus splits into smaller nuclei. How can I split the nucleus? I can split the nucleus by using appropriate projectile. Okay, that I take the nucleus and I hit its nucleus, so it begins to break down like this. Of course, tiny particles used to bombard the nucleus as nutrient, protium, which is the hydrogen 1,1, we say about it sometimes, protium, deuterium, tritium. All these particles are considered to be projectile. Alpha particle, nutrients, beta particles, all these particles are considered to be projectile. Also, in this kind, an enormous or great amount of energy is released. Okay, but it's less than the fusion reaction. Do you see this reaction? This reaction, let us understand it together, and then you have to memorize it. Uranium 92-235, it's very active. Okay. I take its nucleus and I bombard it with neutron. So it begins very, very, very active, to an extent that the nucleus does not even have time to release its energy, so it begins to splits into smaller nuclei. You see here, it splits into krypton 36, barium 56, and during this reaction, while it happens, it releases 3 nutrients. This reaction is called chain reaction. Why it's called chain reaction? Because as you see here, I bombard each uranium with 1 neutron, and this reaction releases at the end 3 nutrients. And these 3 nutrients will bombard 3 other uranium, and each uranium will release 3 nutrients, and so on and so on and so on. So this reaction, I have to control it. The only thing that can control this is by using nuclear reactor. Other than that, if I didn't control it, okay, this reaction will continue forever until you have enough uranium in the reaction. Okay, so if I want to stop such reaction, I use the nuclear reactor. Okay, thank you so much. Okay, let us just summarize here what happens. If I ask you in the exam to compare between fusion and fission reaction, just first of all, the definition, the fusion reaction, you just mentioned that small nuclei combine to form one large nucleus, and in the fission reaction, it's in the opposite way, that large nuclei splits into small nucleus. Okay, then in the fusion reaction, it does not happen except near the sun. Why? Because it needs very, very high temperature. Okay, and we have the only equation here that you have to memorize it, that for each 4 hydrogen, it forms 1 helium and 2 positron and great amount of energy released. Although there is a great amount of energy released, but this reaction cannot happen normally because it needs greater even amount of energy to start such reaction. The fission reaction is the opposite. The large nucleus splits into smaller nuclei. How do they split? That you take a radioactive element and you bombard its nucleus with a projectile, so it becomes very, very, very radioactive, that it does not have even time to release its energy as alpha, beta, or gamma. So the nucleus begins to explode, splits into small nuclei. So you have to memorize this equation. And you have to know here why it's called chain reaction, because as you here hit it with 1 nutrient, it releases 3 nutrients, and each 3 nutrients will hit 3 other uranium, and this reaction will never stop until you stop it with something called nuclear reactor. Okay, thank you so much.